Right now, as you're watching this, you're doing something your brain wasn't designed to do. You're about to understand a distance so massive that it literally breaks human comprehension. A light year. You've heard this term 1,000 times. Scientists throw it around casually when talking about space. But here's what nobody tells you. When you actually understand what a light year means, when you truly grasp the distance it represents, you can never look at the universe the same way again. Because a light year isn't just a big number. It's a distance that reveals how isolated we truly are in the cosmos. And by the end of this video, you're going to understand exactly why even our nearest stellar neighbor might be forever out of reach. Let's start with something you can relate to. Distance. You understand a kilometer. It's about 10 to 12 minutes of walking. 5 kilometers to the store. You know how long that drive takes. 200 kilometers to the next city. That's about 2 hours. These are human-scale distances. Your brain evolved to handle them. You've walked them, driven them, experienced them. But watch what happens when we scale up. The distance from Earth to the Moon is 384,000 kilometers. Already your brain starts to struggle. There's nothing in your daily life that prepares you for this. The Apollo astronauts took 3 days to reach the Moon, traveling at 39,600 kilometers per hour. That's 400 times faster than highway driving. Think about that. 400 times faster than you've ever driven, and it still took 3 days just to reach our nearest celestial neighbor. The sun is 150 million kilometers away. Try to visualize that. You can't, can you? Your brain just sees a really big number, but it doesn't mean anything. Even traveling at the speed of the fastest spacecraft we've ever built, the Parker Solar Probe at 192 kilometers per second, it would still take months to reach the sun. And the sun is close. It's right here in our cosmic neighborhood. We see it every single day. Now here's where it gets absurd. The next nearest star, Proxima Centauri, is 266,000 times farther away than the sun. 266,000 times a distance that already takes our fastest spacecraft months to cover. This is why astronomers needed a different unit of measurement. Using kilometers to measure star distances would be like using millimeters to measure the distance between countries. The numbers become so large they stop being distances and become just abstract symbols on a page. So astronomers created the light year. And before we go any further, let me be crystal clear about this. A light year is not a measure of time. I know it has the word year in it, but it's not time. It's distance. It's the distance that light travels in 1 year. And light is special. Light is the fastest thing in the universe. Nothing, and I mean absolutely nothing, can travel faster. It's not a speed limit we haven't broken yet. It's a fundamental law of physics woven into the fabric of space-time itself. Light travels at 300,000 kilometers per second. Let me say that again because it's important. 300,000 kilometers per second. Every single second, light travels 300,000 kilometers. In 1 second, light could travel from New York to Los Angeles and back 37 times. It's almost impossible to visualize because nothing in our everyday experience moves anywhere near that fast. When you turn on a light switch, the light reaches your eyes essentially instantly. But it did travel. It took time, about 10 billionths of a second. When you look at the sun, you're seeing it as it was 8 minutes and 20 seconds ago, because that's how long it takes light to travel from the sun to Earth. If something happened on the sun right now, if it exploded, we wouldn't know for over 8 minutes. The event would happen, but the light carrying information about that event would still be traveling toward us. When astronauts on the moon talked to mission control, there was always this pause, this 3-second delay, because even radio signals traveling at light speed need time to cross that distance. Light doesn't travel instantly, it has a speed, and that speed, while incredibly fast, is still finite. So a light year is the distance light travels in 1 year at this speed. Let's calculate it. 300,000 kilometers per second times 60 seconds in a minute, times 60 minutes in an hour, times 24 hours in a day, times 365 days in a year, times 24 hours in a day, times 365 days in a year. The result is 9.46 trillion kilometers. That's what a light year is. 9.46 trillion kilometers. Not a measure of time, but distance. The distance that light, the fastest thing in the universe, travels in 1 year. But most people have no intuitive sense of how large a trillion actually is. So let me show you. A million seconds is about 11 and a half days. That's conceivable. Less than 2 weeks. But a billion seconds is 32 years. If you started counting when you were born and never stopped, not for eating, not for sleeping, never, you'd be 32 years old when you reached a billion. The jump from a million to a billion is enormous. Now a trillion. If you counted to a trillion at one number per second, it would take you 31,700 years. Let that sink in. 31,700 years. That's longer than all of recorded human history. Agriculture was only invented 10,000 years ago. Writing systems appeared 5,000 years ago. To count to a trillion, you'd need to have started before any of that happened. Before cities, before nations, before civilization, when humans still lived as hunter-gatherers using stone tools. You'd have been counting through the entire span of human civilization, and you'd still be counting today. Still thousands of years away from reaching a trillion, and a light year is 9.46 trillion kilometers. Every single one of those kilometers is a real distance. The distance you could walk in about 10 minutes. There are 9.46 trillion of those individual kilometer-long segments in one light year. Our brains simply didn't evolve to handle numbers this large. The best way to understand a light year is to build up to it gradually, starting with distances we can comprehend. 1 light second is 300,000 kilometers, roughly the distance from Earth to the Moon and 3/4 of the way back. All of that in one single second. 1 light minute is 18 million kilometers. The sun is about 8 light minutes away. 1 light hour is over 1 billion kilometers. Saturn at its closest is about 1.2 light hours away. When the Cassini spacecraft was orbiting Saturn from 2004 to 2017, there was over an hour delay between when it took a picture and when scientists on Earth received it. This meant Cassini couldn't be controlled in real time. Engineers had to program entire sequences days or weeks in advance and trust the spacecraft would execute them correctly. 1 light day is about 25,900,000,000 kilometers. Voyager 1, launched in 1977 and currently the most distant human-made object from Earth, is about 24 light hours away as of 2025. It's been traveling for nearly 50 years at 61,200 kilometers per hour. That's incredibly fast. At that speed, you could cross the United States in about 2 minutes. And yet, after nearly 5 decades of constant travel through space with nothing to slow it down, Voyager still hasn't traveled one full light day from Earth. 1 light year is 365 light days, 12 light months, 52 light weeks, 8,760 light hours. See how quickly the numbers scale up? We started with 1 light second, already enormous by human standards, and we've been multiplying by larger and larger numbers. And we're just now getting to 1 light year, 9.46 trillion kilometers. This is the fundamental unit astronomers use to measure distances between stars. And now let me tell you why this matters in ways that should genuinely disturb you. The speed of light isn't just fast. It's the speed limit of the universe. And this isn't a technological limitation we might overcome with better engineering. It's a fundamental law of physics. Einstein's theory of special relativity showed that as objects approach light speed, strange things happen. Time slows down for the moving object. Its mass effectively increases. The energy required to accelerate it approaches infinity. To actually reach light speed would require infinite energy, which is impossible. Therefore, nothing with mass can reach the speed of light. This has been tested experimentally countless times. Particles in accelerators moving at 99.9% of light speed live much longer than identical particles at rest. Time is literally moving slower for them. GPS satellites have to account for time dilation, or your navigation would be off by kilometers. This isn't theory, it's measured fact. Only massless particles like photons can travel at light speed, and photons must always travel at light speed. They can't slow down or speed up. This has profound implications that go beyond engineering challenges. Even if we develop perfect propulsion with unlimited energy, even if we solved every engineering problem imaginable, we still couldn't travel faster than light. The 4.24 light years to Proxima Centauri represents a minimum travel time of 4.24 years, even in the most optimistic scenario. Some science fiction proposes ways around this. Warp drives that bend space, wormholes that create shortcuts. But the Alcubierre drive would require exotic matter with negative energy density. No such matter is known to exist. You'd need more mass energy than exists in the entire observable universe. Wormholes would be incredibly unstable and would collapse before anything could pass through. As far as we know, based on over a century of experiments, the speed of light is an absolute barrier. When we talk about stars hundreds or thousands of light years away, we're talking about distances that might be fundamentally unreachable. Let me make this concrete with Proxima Centauri, our closest stellar neighbor. Proxima Centauri is 4.24 light years away, about 40,140,000,000,000 kilometers. If you could travel at the speed of our fastest spacecraft, it would take 6,800 years to reach it. That's longer than all of recorded human history. Writing was invented about 5,000 years ago. You could have started your journey when humans first learned to write, and you'd still be traveling today, still thousands of years away. There have been proposals for faster spacecraft. The Breakthrough Starshot Initiative proposes using powerful lasers to accelerate tiny spacecraft to 20% of light speed. At that speed, a probe could reach Proxima Centauri in about 20 years. But the engineering challenges are enormous. You need lasers with the power of 100 nuclear plants. The spacecraft needs to survive collisions with dust particles that would hit with the force of bombs at that speed. And you get one shot. There's no slowing down. The spacecraft flies past at 60,000 kilometers per second, has maybe a few hours to take pictures, then continues into the void forever. With technology we can actually build today, getting to Proxima Centauri would take not decades but millennia. We'd need multi-generational spacecraft. The people who arrived would be distant descendants of those who launched, hundreds of generations removed, living in a world they'd never left, traveling to a destination they'd only heard about in stories. Now here's where understanding light years becomes truly profound. When you look at stars, you're not seeing them as they are right now. You're seeing them as they were. Light travels at a finite speed. When light leaves a star and travels toward Earth, that journey takes time. Sirius, the brightest star in the night sky, is 8.6 light years away. When you look at Sirius tonight, you're seeing light that left that star 8.6 years ago. If you're 20 years old, you're seeing Sirius as it was when you were about 11. Betelgeuse, the red supergiant in Orion, is about 550 light years away. The light you see from Betelgeuse tonight started its journey in the year 1474, during the Italian Renaissance, before Columbus sailed to the Americas, when Leonardo da Vinci was 22 years old. That light has been traveling through space for over 5 centuries to arrive at your eye tonight. And here's what should keep you up at night. Betelgeuse is a massive star nearing the end of its life. At some point in the next 100,000 years, it will explode as a supernova. But Betelgeuse might have already exploded. The explosion might have happened in 1700 or 1800. We wouldn't know yet. The light from that explosion would still be traveling toward us. If Betelgeuse exploded in 1700, we won't see it until about 2250. The star could already be gone right now, and we'd still see it shining peacefully for centuries, completely unaware we're seeing a ghost. The Milky Way, our galaxy, contains between 100 billion and 400 billion stars. Our sun is just one of these, an ordinary yellow dwarf of average size and brightness, and it's located about 26,000 light years from the galactic center. 26,000 light years. The light from the center of our galaxy left when humans were still hunter-gatherers in the Stone Age, before agriculture, before writing, before civilization. Everything we think of as human history has happened while that light was traveling toward us. The Milky Way is roughly 100,000 light years across. If you could somehow travel at light speed, which you can't, It would take 100,000 years to cross our galaxy. Modern humans as a species are about 300,000 years old. You could have started crossing the galaxy when the first modern humans appeared, and you'd only be one-third of the way across today. Let me tell you about something called the Fermi paradox. Given the vast number of stars and planets, given that the universe is 13.8 billion years old, given that life arose on Earth relatively quickly, it seems likely that life should exist elsewhere, perhaps even intelligent technological life. And yet we've never detected any signs of alien civilizations. No radio signals, no laser pulses, no megastructures, nothing. The universe appears silent. The light year might be part of the answer. The distances are so vast they present insurmountable barriers to communication and travel. Our radio signals have been leaking into space for about a century. They've reached all stars within about 100 light years of Earth, but the Milky Way is 100,000 light years across. We've covered a sphere 100 light years in radius in a galaxy 100,000 light years across. That's a tiny fraction, and those signals are getting weaker as they spread out. By the time they reach stars a few dozen light years away, they're almost impossible to detect above background noise. Think about what communication means when distances are measured in light years. If there's a civilization on a planet orbiting Proxima Centauri, 4.24 light years away, and we sent them a message, it would take 4.24 years to arrive. If they responded immediately, their answer would take another 4.24 years to reach us. That's over 8 years for a single exchange. You could ask about their harvest and receive an answer about crops eaten 4 years ago. Any kind of real-time conversation is impossible. A colony 4 light years away couldn't be governed from Earth. Any laws sent would arrive years out of date. The colony would need to be autonomous, making its own decisions. The colony and Earth would drift apart culturally over generations, developing their own customs, becoming so different they'd barely recognize each other. For a civilization 100 light years away, there'd be a 200-year communication delay. You could send a message and neither you, nor your children, nor your grandchildren would live to see the reply. Here's something that breaks my mind. If you could travel close to light speed, time dilation means time slows down for you relative to stationary observers. Imagine a spacecraft reaching 99.9% of light speed. You travel to a star 10 light years away and come back. From Earth's perspective, this takes about 20 years. But because of time dilation, you would only age about 11 months. You'd step off having aged less than a year, while everyone you knew aged 20 years. Your younger sibling might now be older than you. At 99.99% of light speed, you could travel to a star 100 light years away and back. From Earth's perspective, over 200 years pass. But from your perspective, only a few years pass. When you return, everyone you knew would be long dead. The world would be completely different. You'd return to a future Earth as foreign as if you'd traveled forward in time. The observable universe is 93 billion light-years across, containing an estimated 2 trillion galaxies. Each galaxy contains billions or trillions of stars. The total number of stars in the observable universe is around 200 billion trillion, and most stars have at least one planet. The universe is filled with worlds, more worlds than we could ever count or visit. At the largest scales, galaxies are organized into clusters, superclusters, and filaments, enormous structures stretching hundreds of millions of light-years. The universe is expanding. Space itself is stretching. For distant galaxies, space between us expands faster than light can travel through it. This means there are regions moving away so fast that light from those regions will never reach us. Not in a billion years, not ever. There's a cosmic horizon beyond which we cannot see. We are fundamentally cut off from those regions. This creates a picture of a universe that might be full of life, perhaps even intelligent life, but where that life is forever isolated by vast distances. Each civilization develops alone, asks its questions alone, makes its discoveries alone, and eventually dies alone, never knowing if anyone else was out there. There's something melancholy about this. We've evolved as social creatures. Connection is fundamental to who we are. The idea of being surrounded by others but forever unable to reach them is profoundly isolating. But there's also something beautiful. It means every civilization is precious. If we're alone or effectively alone because we can't reach anyone else, then we carry unique responsibility. We're the universe's way of knowing itself in this corner of space. The thoughts we think, the art we create, the science we discover, all of it is unique to us. We might be the only consciousness for hundreds of light years in any direction. When you realize Earth is a small planet orbiting an ordinary star, that the nearest other star is over 4 light years away, that our galaxy contains hundreds of billions of stars, that there are trillions of galaxies in the observable universe, it changes how you see things. Your problems exist on a tiny planet in a vast universe. That argument, that stress, that anxiety, all of it happens on one small world. The nearest star doesn't care. The galaxy doesn't notice. The universe continues, completely indifferent. This isn't meant to diminish your experiences. Your life matters to you, and that's important. Pain is pain. Joy is joy. These things are real regardless of the universe's scale. But sometimes when things feel overwhelming, it helps to remember you're living on a small planet, orbiting an ordinary star in a vast cosmos. From that perspective, your problems are temporary, local, small, not unimportant, but manageable. There's also something beautiful about understanding light years. When you look at the night sky, you're not seeing points of light. You're seeing stars that are light years away. You're seeing photons that have traveled for years or centuries to reach your eyes. You're connected to those distant suns across vast distances of space and time. You're part of the universe, made of atoms forged in stars, looking up at other stars, understanding your place in the cosmic order. Every star has a story. Some are young, just forming. Some are middle-aged like our sun. Some are old, approaching the end, destined to become white dwarfs or explode as supernovae, all separated by light years, by distances so vast even light needs years to cross them. The universe is sparse, with tiny islands of light separated by enormous oceans of darkness. Yet those islands are connected by light, by gravity, by being made of the same stuff, atoms forged in earlier stars and recycled into new generations. We stand at a unique moment. We're the first generation to truly understand the universe's scale. Our ancestors wondered about the same questions, but didn't have tools to measure answers. They couldn't know stars were distant suns light years away. They couldn't comprehend the vast distances separating us from the rest of the universe. But we can. We've measured these distances precisely. We know Proxima Centauri is 4.24 light years away. We know Andromeda is 2.5 million light years distant. We know the observable universe stretches 93 billion light years. This isn't guessing. It's measurement backed by decades of careful observation. This knowledge changes us. When you understand the nearest star would take thousands of years to reach, when you grasp that light from distant galaxies has traveled billions of years, when you comprehend we might be fundamentally isolated by vast distances, it shifts your perspective on everything. It makes our differences seem smaller. The things we argue about, the borders we draw, the conflicts we engage in, all happen on one tiny planet separated from our nearest neighbors by light years. From that perspective, what divides us seems less important than what we share. It also makes our existence more precious. If we're alone or effectively alone, what we do here matters enormously. We might be the only consciousness in our region of space, the only minds that can contemplate the universe, the only beings who can create art, discover truths, feel love and wonder. That's profound responsibility. We need to take care of this planet, this tiny island of life in the cosmic ocean. We need to preserve the knowledge we've gained. We need to think long-term about the future of humanity among the stars. The light year is more than a unit of measurement. It's a reminder of our place, a reminder we're part of something vastly larger than ourselves, but also unique and precious within that vastness. A reminder the stars are both incredibly far away and intimately connected through light that bridges cosmic distances. Every time you look up, you're participating in something ancient and profound. You're seeing across light years. You're looking back in time. You're witnessing the universe in all its glory. And you're part of that universe, made of the same atoms, following the same laws, connected by the same forces governing everything from the smallest particle to the largest galaxy cluster. That's what a light year really means. Not just distance, but connection. Not just isolation, but belonging. Not just our smallness, but our significance within that smallness. So the next time you look at the stars on a clear night, remember what you've learned. Those points of light are distant suns, each potentially hosting planets and moons. They're light years away. The light entering your eye has been traveling for years or centuries. Some began their journey before you were born. You're connected to those distant stars across vast distances of space and time, linked by light that cross the cosmic void to reach you. The universe is large beyond comprehension. You're small, but you're here and you can understand what a light year means. You can grasp the universe is measured in these vast units. And that understanding, that ability to comprehend your place in the cosmos, is extraordinary. It's what makes us human. We can look up and understand what we're seeing. We can contemplate infinity and our own smallness simultaneously. We can feel both humbled and empowered by the same knowledge. If you found this journey valuable, it would mean everything if you'd hit that like button or subscribe. It helps me keep making these deep explorations of the cosmos. And remember, even though light years represent distances almost beyond comprehension, they're also what connect us to the stars. Every time you look up at the night sky, you're seeing across light years. You're seeing the universe, and the universe, vast as it is yours to explore. May you never look at the stars the same way again.